All right, if we want this function to be continuous everywhere, basically, since it's a piecewise function, what we're really worried about is where this thing splits. We want to make sure that when it goes from -1 to -1, when it goes from this function to this function, that they're going to meet. Okay, so we want this to happen. We want this top function is going to end somewhere. All right, and it's going to be an open circle because it's not equal to. We want this function, x squared plus 1, to start right where this function leaves off, so that whatever it's doing, it meets and it's continuous. If these two pieces right here do not meet, then we're going to get something like this going on. And it's not going to be continuous. So our main goal is we have to make sure that the function's already defined. Okay, the function's defined at -1. We can see that at -1, we plug in -1 into this function and we get 2. What we need to make sure is that the limit as x goes to -1 also equals 2. So that's what we're saying. The limit as x goes to -1 of f of x has to equal 2. Well, that means the right-hand limit has to equal 2. And it also means the left-hand limit -1 from the left of f of x also has to equal 2. Both have to be 2. Well, we can calculate the limit as x goes to -1 from the right. That means we're on this part of the function, x squared plus 1, and as x is headed to -1, this thing's headed to 2. So this already happens. 2 equals 2. No problem. We got to make sure the left-hand limit is also equaling 2. Well, as x approaches -1 from the left, we're on this part of the function. And if x is going to -1, well, then this function here, ax minus b, is headed towards a times -1 minus b, which is -a minus b. Essentially, I plug -1 into this thing, and I'm making sure it equals this part, x squared plus 1, when x is -1. So that's one equation that I have. That's one thing that has to happen. -a minus b has got to equal 2. Otherwise, the limits will not be equal, and it won't be continuous. So -a minus b has got to equal 2. From that same logic, when the function splits again at 2, it goes from x squared plus 1 to this function down here. These two functions have to meet. They've got to equal each other. So at 2, this function, x squared plus 1, equals 5. Well, that means I need this function to equal 5 when x is going to 2, when x is headed to 2. So that's going to give me, when you plug 2 in here, you get 8b minus 2a. So now we have a system of equations. -a minus b has to be 2. And ab minus 2a has to be 5. All I'm going to do is solve for a over here, and we get a is equal to -2 minus b. And I'm going to plug this thing over here for what a is. So we're going to get 5 is equal to 8b minus 2 of what a is. So I'm plugging this in here for a, and that's -2 minus b. There we go. Now I'm just going to simplify this, and this is going to tell me what b is. So 5 has to be 8b plus 4 plus 2b, which tells us that 10b has to be 1, which means b is 1/10. There we go. As long as b is 1/10, this thing will be continuous, but we also got to find out what a is. Well, a is just -2 minus b. Well, -2 is -20 over 10 and minus 1 over 10. A has to equal -21. Not 20ths. Come on now. What just happened there? Going crazy. -21 over 10. There you go. If A is -21 over 10 and B is 1 over 10, then this first piece meets the second piece at -1, and the second piece meets the third piece at 2, which means this thing will be continuous everywhere.